In this video, we want to look at percentage by mass. Now, scientists use percentage by mass to help them work out how useful a substance is, how pure that substance is, and even it can also help scientists to identify an unknown substance. So percentage by mass, also known as percentage composition, tells us how much of an element is in a compound, how much of an element is in a compound. So for example, if I write CO2, percentage by mass of C tells me how much of the C is in CO2. Okay? And the formula for calculating percentage by mass is the relative atomic mass of that element times the number of atoms in the compound divided by the RFM of the compound, i.e. the relative formula mass of that compound. Multiply them by 100 and you get the percentage by mass. So the example I want to use in this situation is nitrogen in ammonia. So calculate the percentage by mass of nitrogen in ammonia, i.e. we want to find out the amount of nitrogen in ammonia. The formula once again is the RAM, the relative atomic mass of nitrogen, multiply that by the number of moles, the number of atoms of nitrogen in ammonia, and divided by the relative formula mass of the whole ammonia compound times 100. So let's have a look at this example here. What percentage by mass of nitrogen is in ammonia? What percentage by mass of nitrogen is in ammonia? Now, you always be given the RAM, the relative atomic mass, that will always be given to you. So you can use that to calculate, do your calculation and find the percentage by mass of the individual elements in a compound. So let's have a look. The first step is to work out the relative formula mass of the whole compound, the ammonia. Calculate the relative formula mass of the ammonia, because remember in the formula we need the relative formula mass. So the first step is to calculate the relative formula mass of ammonia, and to do that we've already gone through how to calculate relative formula mass. The relative formula mass, if you remember, is the sum of the individual relative atomic masses in that compound. The sum of the individual relative atomic masses of that compound. So what we do here is, in the case of ammonia, we have 1 lot of nitrogen and 3 lots of oxygen. So 1 nitrogen plus 3 hydrogen atoms in ammonia. So what we're going to do is that, remember I said it is the relative atomic masses, and the relative atomic mass of nitrogen is 14 multiplied by the number of nitrogen in the whole ammonia compound, and in this case is 1. And we go to hydrogen. We have 3 lots of hydrogen, multiply that by the relative atomic mass of hydrogen, which is 1. And if you add them up, we're going to have 17 as the relative formula mass of ammonia. Okay, so that's the first step. We've got to work out the relative formula mass, and the relative formula mass is the sum of the individual relative atomic masses of that compound. And remember, the relative atomic masses can be found on the periodic table, or it will always be given to you. This time around, we were given hydrogen as 1, nitrogen as 14. Step 2, you then move on to work out the percentage by mass by putting them in the formula. Now, the formula says that the percentage by mass of nitrogen in ammonia is going to be the RAM, the relative atomic mass, times the number of nitrogen in ammonia, divide that by the relative formula mass of ammonia. So let's put them in. The RAM, the relative atomic mass of nitrogen, is 14. Multiply that by the number of atoms of nitrogen in ammonia, that is 1, and divide that by the relative formula mass, which we just calculated as 17. Put that there, multiply by 100, and you will have 82. Okay, so the percentage by mass is by calculating the amount of the element in the compound that has been given to you. And the formula is the RAM times the number of atoms of that element divided by the relative formula mass times 100. So let's look at another example here. We've got what is the percentage by mass of hydrogen in ammonia. Remember, we just calculated the percentage by mass of nitrogen. This time around, we are looking at hydrogen. Feel free to pause the video and have a go. Pause the video and have a go. Use the same formula. The percentage by mass is the relative atomic mass of that element multiplied by the number of that element in the compound divided by the relative formula mass and multiplied by 100. So step 1, we are supposed to work out the relative formula mass of ammonia. That is the compound we are dealing with. So let's go ahead. We have already done that and we got 17. The next step is go ahead and calculate the percentage by mass by putting them in the formula. So let's have a look here. We got percentage of hydrogen in ammonia will therefore be the RAM of hydrogen multiplied by the number of atoms of hydrogen in the compound divided by the relative formula mass of the whole ammonia compound and multiplied by 100. So let's go ahead. RAM of hydrogen, the relative atomic mass of hydrogen is 1. That was given to us in the question. Multiply that by the number of hydrogen in the compound. We have 3 lots of hydrogen, so bring 3 here, or multiply that by the coefficient of the element in the compound. The coefficient of nitrogen is 1. In chemistry, we don't write 1, and the coefficient of hydrogen is 3. So we are looking for the percentage of hydrogen in ammonia. So we go on, use the relative atomic mass of hydrogen, multiply that by the coefficient, which is 3, and divide that by the relative formula mass, which we have already calculated, and multiply by 100. That should give us 18%. So that's how we calculate percentage by mass. Put them in the formula. Start by working out the relative formula mass, and then use that to put in the formula to calculate the percentage by mass. Let's have a go at this one. Pause the video and calculate the percentage by mass of oxygen in all these compounds. Percentage by mass of oxygen in magnesium oxide, in potassium oxide, sodium hydroxide, and sulfur dioxide. Calculate the percentage by mass. Pause the video and have a go. Okay, I hope you got them correct. Let's look at this one. How much nitrogen does each fertilizer contain? We have 3 types of fertilizer, and we want to find out the amount of nitrogen in each of them, and we can do that by calculating the percentage of nitrogen in each of the fertilizers. The first fertilizer is Mega Pumpkin, and the formula for this is NH4NO3. The super grow is NH4 into bracket 2 SO4, and the plant B bay is CON2H4. Now pause the video and calculate the percentage by mass of nitrogen in each of these fertilizers. Pause the video and calculate the percentage by mass of nitrogen in each of them using these formulas. You got to calculate the relative formula masses of each of them, okay? And then use the number of nitrogen in each of them to calculate the percentage by mass. The one with the highest percentage is the best fertilizer. The one with the highest percentage of nitrogen is the best fertilizer. Okay, so if you do your mass well, you should get mega pumpkin percentage by mass of nitrogen in it to be 35%, super grow is 21, and plant B big to be 47%. Okay. Now, so from this result, we can see that plant B big contains the highest percentage of nitrogen. Okay, and so that is the best fertilizer to be used. In the next video, we will have a look at empirical formulas and then look at some calculations around empirical formulas. We will use empirical formula. We will calculate empirical formula from molecular formula.